the physics concept power. Power is the rate at which work is done, or the rate at which energy is consumed, or the rate at which energy is used. It's a rate, just like velocity is the rate of change of position, and acceleration is the rate of change of velocity. Power is the rate at which work is done, or the rate at which energy is consumed, etc. Power uses a lowercase p, not that you can tell the difference the way I write it. Again, it's a rate, and so it's work all over time, the rate at which work is done. And so the units of this, will be in a joule per second, because remember that work is the rate at which energy is transferred over time, a joule per second. Well, we've named that after a dead Scottish scientist by the name of James Watt. So the SI unit for power is a watt, and a watt is a joule per second. It's an uppercase W because it's the first letter of his last name. How can you tell the difference between a W for work and a W for watt? Well, this is a unit, not a variable. Interesting note, power is the rate at which work is done. It is also the rate at which energy is consumed or used. So when you turn on that 60-watt light bulb, what does that mean? It means that you are using 60 joules of energy every second you leave that light bulb on. 60 joules of energy every second. So in a whopping 1 minute, that's 60 seconds times 60 joules every second. You've just used up, what's that, 3,600 joules of energy. What does that say? It says that that 60-watt light bulb, it's not very energy efficient, but it also says that a joule is a very small number, a very small unit of measure. It's a little bit like measuring electrical use in joules would be like measuring the distance from here to the moon in inches. It's not a very good unit to measure with. But that's power. If I lift up on this heavy-duty whiteboard marker, all right, as I lift this thing up, I do work on it as it moves upwards. And it takes a certain amount of time for me to lift that up. And so the amount of work I do divided by the time it took will tell me my power output. As you all know, my wife is way more powerful than me. She can lift up the same whiteboard marker in half the amount of time. She's much faster. Whoop! Well, she does the same amount of work if she lifts it the same distance. But she can do it faster. She's in less time. She's more powerful. That's the idea of power, the rate at which work is done. There is one other way to calculate this. If you know how to calculate the work, force times the displacement times the cosine of the angle, and you can figure out the time. You could also do this. Now I'm going to do a real quick proof. You know that, loosely speaking, work is force times distance. All right, force times displacement. All right, times the cosine of the angle, I know. All over the time. And you also know that displacement over time is velocity. So another way to calculate this is just a second equation for power, is that power equals force times velocity. Both of these equations work. Pun was intended, I apologize.